Okay, so in this particular lecture, we are going to study about the binary to decimal conversion. But this is different from the traditional method. It will provide you a faster way, or you can say a quicker method to convert binary to decimal. This method is nothing but it requires a better memory. So, as you are aware that you need to remember this 2 raised to the powers. So just see 2 raised to the power 0 is 1, 1 is 2, 2 is 4, 3 is 8, 4 is 16, 5 is 32, 6 is 64, 7 is 128, 8 is 256, 9 is 512 and 10 is 1024. So this method is up to 11, 10 bits, it's fast, and it will not require even a pen to write anything. You just can see the number and find out the decimal equivalent of that particular number. Beyond that, you have to remember the powers of 2, and then you have to use some pen paper for the summations. So this particular method comes with two cases. The first case is when you have number of zeros greater than 1, and the second case when your number of zeros are less than 1. So in the first case, when you have number of zeros are greater than 1, we use the additive method. So let's see with the example then what is additive method and how this is used. So suppose you have an 8-bit number which is like 100010001. So you can simply see that in this particular example, number of zeros are 5 and number of ones are 3. So obviously number of zeros are greater than 8. So why this case is used? This case is used because we are going to use the additive method, and we want to make it faster. So we use addition over here, and what we want, we need to have number of operations lesser. So if number of operations are lesser, then the output will be faster. So in this particular example, what we have to do now, we have to find out only those values or place values where ones are present, because anyways when you multiply anything with 0, it will become 0 only. So just what you have to see that where there are 1, find out the place value and then find out the sum. So this is 2 raised to the power 0, this is 2 raised to the power 3, and this is 2 raised to the power 7. Fine. Then just find the sum. So it will be like 128 plus 8 plus 1. So 7, 3, 1. So 137 is the answer. So you can see that only we have to use the 3 additions to find out the decimal equivalent. So the decimal equivalent of this number 100010001 is how much? 137. So in this particular example, I have demonstrated it by giving the writing the numbers. When you come into practice, you don't even need to write the summation. If your mind is capable enough to find the summation, then you don't need to write them as it is. Let's take one more example of this. Suppose your number is 001001000. Fine. So this is your number. So now you have to find out the two summations. So this is 2 is power 0, 1, 2, 3, 4, 5. So you can simply say that the number in decimal will be 32 plus 4, that is 36. Fine. So in this particular example, you have seen that I have reduced in the writing. So you can use this method to find out the binary to decimal conversion in a faster way. Now second case, when the number of zeros are less than number of ones, so at that point you need to have the other method, because if you take one example, like if your number is like 1111001, fine. So in that particular example, you can see that 1 2 3 4 5 6, Total we have 6 addition operations. So if we can replace this particular number of operations to some simpler method, then it will be more efficient. So for that we use the second method, that is known as the subtractive method. So in the subtractive method we have to memorize something different. What we have to memorize, just see. You simply knows that if there is 1 1 1 1, this value is 15. Okay, if you have number like 1 1 1, this number is nothing but 7. Or a generic formula is present, that is known as 2 raised to the power n minus 1. That means if we have n bit number, if we have n bit number with all ones, then the value of that particular number will become 2 raised to the power n minus 1. So based on this we just write the numbers. So we have, if the number is like all zeros, leave all zeros. If your number is 1, then the value is 1. If your number is 1 1, then the value is what? 2 raised to the power 2 minus 1, that is 3 only. Then if you have a number, this is binary and this is decimal. If your number as 1 1 1, then this value will become 7. If you have 1 1 1 1, then this value will become 15, and so on. You can find out any value. Now let's take this method into action. So suppose if you have a number as 1 1 1 1 1 0 1 1, if your number is this. So if you are going for the additive method, then you have to have these many addition operation. But what we have to observe in that, if there is no zero in this particular example, then what will be the value? So if there will be no zeros, then this particular binary value will be equivalent to how much? Will be equivalent to 255. How much? Because it's a 8-bit number, so 2 raised to the power 8 minus 1, that is 256 minus 1, 255. So if you compare this number, what is the difference between that is at this place value? Okay, if at this place value the number was 1, then the value will become 255. Now since there is a 0, so what we can do is just simply subtract this value. That means this is 2 raised to the power 0 1 and 2. So in this particular number, what is missing? 2 raised to the power 2, that is 4. So simply subtract this value where there is a 0. So the value will become 251. This is why this method is known as the subtractive method. Because instead of addition, what we are doing, we are subtracting the number from that particular value. Let's take one more example. So suppose if your number is 1 1 1 0 1 1 1 0, this is the number. Still this method is useful. So this is 2 raised to the power 0, then this is 2 raised to the power 1 2 3 and 4. 2 raised to the power 4 is nothing but 16, and plus 1 17. So 2 raised to 255 minus 17 will give the answer. So this will become 8, this will become 3, and this will become 10. So the decimal equivalent will be 238 of this binary number. So in this way you can find out the faster conversion between the binary to decimal number. You have to observe that if the number of ones are lesser and larger. Okay, now let's see how we can convert a decimal number to a binary number in a faster way. So again we have to use the same values that we have remembered for 2 raised to the power 2 raised to the powers. So suppose we have a number as 1028. This is decimal and we have to find out the binary equivalent. Now you can simply see this thing that we are not going for the division. Okay, So just write, just find out a value that is nearest to this value and that is divisible by 2 raised to the power something, or that is greater than 2 raised to power nearest value. That means we have to find out the value of n that is 2 raised to the power n is less than this number nearest value. Okay, so we can simply see that this is nearest to 1024. So what we do, we just write 1 at the place value of 2 raised to the power 10, because if there is a 1 at 2 raised to the power 10, then this value will become 1024. Then just simply subtract 1024 for that, so that we left with 4 value. So for the rest value like 2 raised to the power 9, 2 raised to the power 8, 2 raised to the power 7, 2 raised to the power 6, 2 raised to the power 5, 2 raised to the power 4, 3, 2, 1 and 0. So actually when this number is just less greater than 1024, then the length of your binary string is already pre-decided as 2 raised to the power 10. Now next value we have to find out, that is the remaining value. So there will be 0 at 2 raised to the power 9, 8, 7, 6, 5, 4, 3 and at 2 raised to the power 1, if you put 1, then this will become 4 and the remainder is 0. So after this we just put the 0 0. So in this way you can find out that the binary equivalent of 1028 is nothing but 1000 0000100 is the value of the binary equivalent. So this is for the decimal to binary conversion quicker method. Let's take one more example for the same. Suppose your number is 547. Okay, this is in decimal and you have to find out the binary equivalent of this. So 547, so we have to find out the nearest value. So it is coming out to be the nearest value is nothing but 512, that is 2 raised to the power 9. Simply subtract that 512 from this, so this is coming out to be 35. So first write that it is having 1 at 2 raised to the power 9 position. So the number will be 1, 2 raised to the power 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, after this 35, so 35 is nearest to 32. 32, that means till 2 raised to the power 5 we have 0. So when we put 2 raised to the power 5 1 value, then it will become 32. After 32 we will left with 3 only. So again 0 0 0 1 and 1. So this will become the binary equivalent of the number 547, that is 1000010001. So this is again faster, and when you are become more efficient, then you simply write the number. Like for a smaller number it can be done very easily. Like if your number is 67, so 67 is what? 67 is 64 plus 3. So you just write 1, so this will be 64, then 32, then 16, then 8, then 4, then 2 plus 1. So this is the binary equivalent of the decimal number, and I haven't used anything other than writing the simply number. Now let's take another example as 39. So 39 is in decimal, you have to convert it into binary. So just write, it will be 32 plus 16 will be 0 for 16, then 0 for 8, then 1 1 and 1. So this will be the decimal equivalent. So similarly you can do it. The more you practice, the easier you will do the same thing.